Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 4, Section 4, Parallel and Perpendicular Lines. There's two parts to this video, so tonight we're doing part 1. So why? Notice the squares, rectangles, and lines in the piece of art shown on the right. Some of the lines intersect forming right angles, other lines do not intersect at all. So there's some right angles here, that means 90 degrees, and some lines, like this red one and this yellow one, they don't meet at all. Okay, that means they are parallel. Parallel lines. Lines in the same plane that do not intersect are called parallel lines. Parallel lines have the same slope, so when they're going towards the same directions, these two lines will never meet, these two lines will never meet. Okay, that means they're parallel and they have the same slope. Okay. Parallel line through a given point. Write an equation in slope-intercept form for the line that passes through negative 3, 5 and is parallel to the graph of y equals 2x minus 4. So when a line is parallel, the slope is equal. They're congruent. They're the same. The slope of a line with the equation y equals 2x minus 4 is 2. So the line parallel to y equals 2x minus 4 has the same slope of 2. So that's what we get from here. The slope will be 2. Now, you're going to write the equation because you have a slope and you have a point. So let's write it in point slope form. So now m is 2 because it's parallel to this line here, and that's the same slope, so 2. And you have this line going through negative 3 and 5. So this is x and y, so we're going to put negative 3 and 5 here. Now when we simplify this, minus a negative makes it a plus, okay? And then we're going to further simplify this and make it into slope-intercept form by adding 5 to each side. That cancels out. Now we have y equals 2x plus 11. And there's your final equation in slope-intercept form. Now we did all this because going back to direction, it says write an equation in slope-intercept form. So we did all that because the direction tells us to do it in slope-intercept form. Next, we're going to do your turn number 1. Write an equation in point slope form for the line that passes through 4, negative 1 and is parallel to the graph y equals 1, 4, x plus 7. So what we get from here, its slope is the same when it's parallel, and it passes through 4 and negative 1. Okay, so go ahead and do that. It said leave in point slope form, so you just want y minus y1 equals m times x minus x1. Okay. Alright, so go ahead and do number 1, come back when you're done. Alright, welcome back. We're going to move on to perpendicular lines. Okay, perpendicular lines. Lines that intersect at right angles, that means 90 degrees, are called perpendicular lines. The slopes of perpendicular lines are opposite reciprocals. Okay, keep that in mind. The slope of perpendicular lines are opposite reciprocals. Okay, that is, if the slope of a line is 4, the slope of a line perpendicular to it is 1 over 4. So I like to say change the sign upside down. So what I mean by that, when you have a slope of, let's say, 2 over 3, let's say 2 over 3, the perpendicular slope will be change the sign, that's a positive, so change it to negative, and flip it upside down, 3 over 2. Okay? So these two slopes are perpendicular because they are opposite reciprocals. That means change the sign, opposite signs, and upside down. So if I have a slope of here, example 4, 4 is the same thing as 4 over 1. Okay? So this is a positive, so we're going to change it to negative 1 over 4. Okay? One more example. If I have, let's say, negative 1 over 5, okay, change the sign. Now it's going to be a positive. Upside down, 5 is same as 5 over 1. So these two slopes will be perpendicular. Alright, so opposite reciprocals, again, the opposite reciprocal, if a over b, is negative b over a, because their product is negative 1. Okay, so here's a real world example 2. Slopes of perpendicular lines. Design. The outline of a company's new logo is shown on the coordinate plane. So here's a new logo. If angle DFE is the angle DFE a right angle in the logo? Look at DFE. Okay, so this angle here, is that perpendicular? Well, we'll have to find the slope of this line and find the slope of that line and see if they are perpendicular. So slope of BE, this slope here, we're going to find by doing y2 minus y1 over x2 minus x1. So if you want to write out BE, B is right now positive 1, 2, 2, and x is 2, y is 1, 2, 3. Okay, and your E, your coordinates are 1, 2, 3, 4, 5, 6, 7, and your y is 1. Y is 1. Okay. So here you go. You have x1, y1, x2, y2. So did 3 minus 1, 1 minus 3. Then you have to do 7 minus 2. And you have a slope of negative 2/5. Okay. We're going to do the same thing for AD, line AD. Okay. So A has coordinates of 2, 1. And then D has coordinates of 1, 2, 3, 4. And your Y is 1, 2, 3, 4, 5, 6. So with these points, you're going to do y2 minus y1 over x2 minus x1. So 6 minus 1 on the top, 4 minus 2 on the bottom, and you get 5 over 2. Now negative 2 over 5 and 5 over 2, do they have a relationship? Yeah, they're opposite reciprocals. You notice the sign is changed and they're upside down. So therefore it is a right angle. Alright. Moving on to next question. Is there a pair of opposite sides parallel? So are there parallel lines here? Okay, so if a pair of opposite sides are parallel, then they have the same slope. So slope AC, you're looking at this slope here and that slope here. They're undefined because they're going up and down. So since AC and GE are parallel to the y-axis, they're vertical and are therefore parallel. So you can tell this line is parallel to the y-axis and this line is as well. So they are parallel. So they are horizontal and therefore parallel. Alright, so here's your turn number 2. Construction. On the planes for a tree house, a beam represented by QR has endpoints Q and R. A connecting beam represented by ST has endpoints. Are the beams perpendicular? So you're going to find the slope for this. And then, whoops, I don't want to cover that part. Find the slope for QR. And then you're going to find the slope for ST. And then if they have opposite reciprocals, then they will be perpendicular. Okay, so go ahead, do number 2 and come back when you're done. Oh, actually, when you're done with number 2, you're done with tonight's homework, and then come back for tomorrow for part 2 of this section.